All right, so we are going to start Unit 2. Unit 2 is a little bit of review of some of the stuff we've already done, but then we're going to do it in different ways. We're going to get a little bit more complicated. We're going to be doing different types of calculations. So to start off with, we're going to be doing a little bit of reviewing on balancing equations, how to classify them, how to figure out their products, and then we're going to get into a little bit new stuff where we have to figure out chemical quantities. We're going to do a little bit more stoichiometry, and then lastly, we're going to figure out how to come up with empirical and chemical formulas in a little bit of a different way than we've done before. So I just got a new writing tablet, so we'll see how this will go. So to start off with, let's do a little bit of review of just balancing, how to balance an equation, so on and so forth. So chemical reactions, first of all, we have reactants and products. The reactants are written on the left side of the arrow. The products are written on the right side of the arrow. You can have one or more reactants. You can have one or more products depending on the type of chemical reaction. Word equations. Okay, so an example of a word equation is if I just tell you we're taking iron, we're mixing it with oxygen to form iron oxide. And if you notice, if you remember, that when we write it in words, we have to include the 3 telling me that this is iron 3, so we're dealing with the iron with a charge of positive 3. So that way when we try to do the next thing, which is writing chemical equations, we'll be able to write them with the symbols. So word equations use the word of the element or the compound, and chemical equations use the element symbols. So for instance, if we take iron oxide and convert it into the chemical equation, we have iron, which is Fe. We're mixing it with oxygen, which is O2. And then if our compound iron oxide, iron has a charge of +3. We know this from up here. Okay, oxygen has a charge of -2, so you kind of cross multiply them, 2, 3. That means we need 2 irons for 3 oxygen. So now we have a charge of -6 and a charge of +6, so this makes this a neutral compound. Okay, sometimes these are representing the phase that the material is in. So iron is in the solid phase, oxygen is in the gas phase, and then iron oxide is also in the solid phase. You guys, iron oxide is rust. So we know that it is in the solid phase. Now, sometimes it's really necessary for you to use these phases. Sometimes it's not as necessary to put them in. The way I look at it is, you know iron is a solid. We all know what iron is, so I expect you to put the solid there. Okay, we know oxygen is in gas form. We know iron oxide, which is rust, is in solid form, so I expect you to be able to write those. So if you know what form they come in, I want you to try to practice putting them in. If you're unsure, you can leave it blank for now, and we'll get there as we go through this unit. Okay, so another example, this is hydrogen peroxide. If I take hydrogen peroxide and I add right here, if you guys remember, this is where you add a catalyst. Last week we did an experiment in which we used heat. This time, if we add manganese oxide to my hydrogen peroxide, it acts as a catalyst, and it will cause it to break apart into H2O, water, and oxygen. And if you notice again, we see O2. We're going to talk about that again in just a second. But remember, up here is where you write your catalyst, and this is kind of telling you that this is required to make the reaction happen, but at the same time, it is not used in the reaction. So manganese oxide is also going to still be present after the reaction has happened because it's just jump-starting the reaction. It's not affecting it at all. Okay, so when we are balancing equations, you need to remember that both sides of the equation must have the same number of atoms for each element. Okay, only coefficients can be adjusted to balance an equation. You never ever change the subscripts. If you change the subscripts, you're affecting the compounds. Remember, compounds need to be neutral. Compounds need to be, if they're covalently bonded, they need to all be following the octet rule. So if you change the subscripts, you're changing the charges. You're changing they're meeting the octet rules. So we have to look at coefficients. Once you write your skeleton equation, which is just the elements and the compounds that you're using in the reaction, you no longer can change them. You have to be adding coefficients. And if you've forgotten what a coefficient is, the coefficient is what goes out in front of the number. Okay, so for instance, here we have carbon, which is in solid form. Carbon is pencil lead. mixing with oxygen, which oxygen we all know is in gas form, and when they mix together, we are getting carbon dioxide. We also know carbon dioxide is in gas form. Now, is this a balanced equation? Yes. If we needed to balance it, we would have to add coefficients out in front, but this is already balanced, so we don't need to add anything to it. Okay, another one. Here we have H2, hydrogen, which we know is a gas, mixing with oxygen, which is a gas, giving us water, which we all know water at room temperature is a liquid. Now, you can see that I've added coefficients of a 2 here and another coefficient of a 2 here to kind of help balance the equation, because if you notice here, we have 2 here and 2 hydrogens here, but we only had 1 oxygen where we had 2 here. So we had to fix the oxygen. In the process, that also increased our hydrogen, so we had to go over here and add a coefficient on this side as well. Okay, so for those of you who don't remember your diatomic molecules, we've already talked about this a little bit this year, but we've done it here with oxygen. We've done it again down here with hydrogen and oxygen. These guys always exist in 2. These are called your diatomic molecules. There are 7 of them. They make a 7 on the periodic table. I don't always necessarily say them in this order because that's not the order they occur on the periodic table, but it's a little bit easier to remember. We have nitrogen, oxygen, fluorine, chlorine, bromine, iodine, and then of course hydrogen. Okay, these always exist in pairs. They are never ever by themselves. They don't have to be in pairs when they're in a compound like we see up here. Oxygen's by itself now, but he's bonded to hydrogen. Only if they are all by themselves do we have to write them as diatomic molecules. They are in their pure form. Now, there's also 2 more elements that I want to talk about that we didn't necessarily talk about in chemistry a whole lot. This would be sulfur and phosphorus. Sulfur, if we have pure sulfur in its elemental form, it's never by itself either. It actually exists as S8. So it's breaking the octet rule, and I'll explain it a little bit further in a little bit, but S actually occurs as 8. Phosphorus also doesn't exist as a diatomic molecule, but it exists all by itself in a set of 4. So sulfur is never by itself, and phosphorus is never by itself. They exist in 4 and 8. So keep that in mind as we start balancing equations, so that just like whenever we see oxygen and hydrogen, you know to put 2. Whenever you see sulfur and phosphorus, you should also know to put 8 and 4. Okay, so we have all balanced equations before, and I've taught you guys an easy way where we just kind of tally up what's on the left side and we tally up what's on the right side, and then we can kind of trial and error it to get to the right answer. That is one way to do it. There's actually a second way to balance equations, and it's called the matrix method. It's not necessarily easier, but when we get to complicated equations, kind of like the one you see here, it's a lot easier to use the matrix system than it is to use the trial and error method that you guys have done before. So just kind of whichever one you prefer. I'm going to make you guys do it this way for a few trials just so you learn how, because I think it might come in handy as we get to a little bit more complicated equations. So basically what we do is we take our equation. So up here we're taking calcium phosphate, and we're taking sulfuric acid, and we're mixing them together, and we're going to get calcium sulfate and phosphoric acid. Okay, so this is what you do. Instead of adding coefficients, usually we would add a coefficient out in front of here, and in front of calcium, and in front of hydrogen. If you notice down here, I put A, B, C, D. Those are kind of like place holding our coefficients. That's where we're going to plug in our coefficients. So instead of writing out all of the elements and doing the trial and error, this is another way you can do it. Basically, you do each element or combination of elements at a time. So let's start with calcium. So let's make a grid indicating the appearance of the element or ion in each species of the equation. Use a whole number and the coefficient letter, so the letter is A, B, C, or D, to indicate each appearance. So first of all, let's start off with calcium, and I've already filled this out, so let's just go through it. Okay, calcium is up here. In the A spot, we have 3 calciums, so I'm going to write 3A. Okay, in the B spot, we have no calcium, so that's why I put 0. In the C spot over here, if you look up here, we have 1 calcium, so technically this is 1C, but we don't need to put the 1. And then if we look in the D spot, we have no calciums, so that's why that is a 0. Okay, so now I have written my equation for calcium, so now let's go on to phosphate. You're going to do the exact same thing. Phosphate, if you look up in the A spot, we have 2 phosphate, so I'm going to write 2A. In the B spot, we have 0 phosphate, so I'm going to write 0. In the C spot, we also have 0 phosphate, so I'm going to write 0. And in the D spot, we have 1 phosphate, so that's why I've written D, or technically 1D. Okay, let's go ahead and do the same thing for hydrogen and sulfur, or sulfate. Hydrogen, if you look in the A spot, we have 0. In the B spot, we have 2. In the C spot, we have 0. And in the D spot, we have 3. Okay, looking at sulfate, we have 0 in the A spot. We have 1 sulfate in the B spot, so that's why I've written 1B. We have 1 sulfate in the C spot. And then we have 0 sulfates in the D spot. So now I have written kind of like 4 separate equations. Now, this looks complicated, but I bet you after you do it a few times, it'll get much simpler. So now what we are going to do is we are going to try to simplify the equations a little bit. So, first of all, I'm going to assume A equals 1, and I'm going to reduce each equation. So, if we look at the first equation, we wrote that 3A plus 0B equals 1C plus 0D. So if I simplify that, I'm going to get 3A equals C. If we look at the second equation, we throw out the zeros, we get that 2A equals 1D. With the H equation, we can simplify that to equal 2B equals 3D. And with the sulfate equation, we can get 1B equals 1C, or just B equals C. So now that I've kind of simplified them, it makes it a lot easier. So now what I'm going to do is I'm going to plug in 1 for all of my A's. So if I plug in 1 for my A, I'm going to get okay, so let's come down here. I'm going to try out my pen. Okay, so if we come in here, if we plug in a 1 right here, 3 times 1 is 3. So right now we know my A equals 1. Okay, 3 times 1 is 3, so that means my C equals 3. Okay, if we come down here and we plug in a 1 right here again, 2 times 1 is 2, so that means my D equals 2. So now we have A, C, and D all figured out. So now we just need to figure out what B is. So we could use this equation and do a little multiplication and a little division, or we could jump down here to this where we see that B is also equal to C. So since B is equal to C, we can also say that B is equal to 3. So now we have done step 4. We have solved for the coefficients. So now I see that A is equal to 1, C is equal to 3, B is also equal to 3, and D is equal to 2. So now I need to finish, and I need to finish writing out my equation. So here is the base equation from before where we had A, B, C, and D holding the spots of our coefficients. We just figured out what A, B, C, and D are through the math, through the writing the different equations. So if you plug in the coefficients, you get that 1 calcium phosphate plus 3 sulfuric acid gives you 3 calcium sulfates plus 2 phosphoric acids. So, and as you have noticed right here, you can see that I have added the 1 in here, and you can kind of see that I graded out. The reason I've graded out, as you guys remember, is you don't always need to write the number 1. You can put it in there if it helps you remember to fill in the blanks. You know, it kind of serves as a placeholder, but writing a 1 there can kind of be redundant. But if you want to put it there, it helps you remember that A is equal to 1. Also, sometimes you'll get fractions. Oftentimes, when you're dealing with oxygen, you'll get a fraction. So if you get fractions, you need to get rid of them. What you do to get rid of the fractions is you need to multiply by the lowest common denominator. So for instance, if I have a fraction of 3/2, my denominator is 2, so I'm going to multiply all of my coefficients by 2 so that I can get rid of that fraction. So when we get to an example of that one, I'll kind of walk around and help you if you get stuck. But yes, if you do get fractions, you need to try to get rid of them.